to get the answer by now, you should do more exercise. You should roughly solve this question in 10 minutes, 10 to 15 minutes. If you're unable, you need to practice more. Okay, I give you the final answer. This diagram is expected in your solution. Remember, when you draw, don't combine two arrows together. Have some gap, or you can just draw two arrows so that I can see there's two components there. Okay, like for example, this overlap one, you can draw just below the x-axis just to point the arrow. So how do I give marks? This got 1, 2, 3, 4, 5. Usually this one will be 3 marks. So 1, 2, 3, 4, 5. 5 arrow will be about 4 marks or 3 marks. Then the axis correctly, the arrow pointing correctly will be another 2 marks. Roughly like that. Okay. So you split, then you get the final answer. You should get negative something for the x component. Okay. Y, you should get something for positive for y. So here, remember, if there's no component, please write 0. Don't assume I know. For y, this one, although don't have y, please write 0. Or in your calculation, you write F1y equals 0 Newton. It's a free marks. Combine these two. Okay, combine these two. So this notation and this notation is just to help you to draw the resultant forces. So this one negative, because negative and in general to the right is positive, you get negative means you flip to another direction. You should get this diagram. Calculate the angle, tangent, this one, find the angle. Okay, angle will be magnitude, you need to find. Square this one, square this one. This one, How you get this equation? Why you suddenly get square, square, square? Based on triangular rules also. C square equal to A square plus B square. So C equal to square root A square plus B square. This is how this equation comes from. Angle will be 37.8 degree. Remember to put the degree. Okay, there's a fundamental problems, extra homework. If you want to do, you do. If you want to know the answer, come to my office. I can show you the answer if you want. All right. Okay. Second half, we go into Cartesian vector. We go into vector operation. Vector operation. It's a revision for vector chapter. But I'll go very fast. When you do vector, remember your right hand. Because every time you see Cartesian vector, look at your right hand, and your thumb is always the direction of the rotation. Your finger is the force. Okay, it's a force direction, right? So this is right hand rules, X, Y, and Z. So your finger is always your Z direction, right? Your X and Y, it depends. It depends. It means what? If you do right hand rules, this is the axis that you focus on, not necessarily always Z lah. Your thumb is always the axis. Your right hand rules can flip to X. Flip to X, then it become like that. Okay, flip to Y, your thumb pointing along Y. Your finger is like this. Finger is the rotation that they give you positive value. Okay, so it depends on where you see lah. If you see from the back, if you go inside the screen, the rotation is clockwise. If you come out from the screen, rotation is anti-clockwise. It depends on the axis you see. Sometimes X will be pointing out, Y will be pointing this way, Z will be going up. Important, this one. So it's where you describe. So this is the general direction for x, y, and z. Okay. Now, just now I mentioned, when you know you need to use Cartesian vector analysis, when you see three-dimensional cases, like what you see on the screen here, right? You see there's a vector, resultant vector pointing in all the direction of x, y, and z. And you can split the blue color into x-axis, y-axis, and z-axis. Okay? How you split? You go to the origin. Then, okay, at first you have a plane first. You draw a plane. You draw a parallelogram on the z-axis. So A will split to AZ and A prime. Okay, first, how you solve three-dimensional vector? You're given x, y, z axis and a blue color arrow. The next step is you draw a parallelogram or you draw a square of this one. First, you use your ruler to copy the z-axis. You move your ruler to the pointer of the blue arrow. You draw one line. Then here also you AX and AY, this one later, you just assume one angle, you find one angle, just draw so that you can draw a parallelogram here. So A will split to AZ and A prime. A prime is a resultant. Also, use a resultant concept. Split A prime into X and Y. This one already did just now. A lot of time, right? So just this one for three-dimensional, you only need to do 2 times the splitting of component. You need to split 2 times. One is the resultant to the Z and A prime. Then split one more time for A prime into X and Y. You need to repeat 2 times of splitting into component. Okay. The rest you read. This is what I mentioned just now. A equal to AZ plus A prime. You split into 2 components. Then this one also you split into X and Y with this equation. So you combine this one, you substitute, you pull this one, substitute inside here. The resultant of A will be AX plus AY plus AZ. Yeah. So every time you have a resultant in three-dimensional, you can split them into AZ, AY, AX. Okay. So if you see 3D, just extend your equation in Z-axis. Just now, the exercise just now is only X and Y. If you have Z, add one more Z. Okay. So again, we put in the unit vector again. I is unit vector, magnitude is 1, direction is along the x-axis for I. J, magnitude is 1, J is along y-axis to the right. K is magnitude is 1, positive, go up in Z. Okay. So in this case, we pull the understanding in unit vector into this diagram. Okay. Now, just now we are finding the magnitude of AX. You put inside the I, it becomes a vector already. Okay. So this one is just a repeat of the 2D into 3D, like what you did just now. Vector Cartesian vector notation. You just need to add one more, which is J. So it will become this one. So F equal to Fxi plus Fyj plus Fzk. This just need to add one more. Okay. The rest you read. Oh. Next, because it's a vector, so vector and magnitude and direction. So in three-dimensional, don't use tangent. Tangent only apply in 2D. In 3D, there's a way in solving it. Magnitude also same. You square, square, square. Why you can use square, 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 square? I start with blue rectangular. It is this one. You split, right? So blue rectangular. How you get the rectangular magnitude? A square equal to this square plus this square. Gray, which is the bottom one, this one. Because you split this one into X and Y. So there's a gray color rectangular. So gray color also same. X square plus Y square. Okay, this is C. C equal to this side square plus this side square. Then you eliminate the A prime, substitute inside there. You get A square plus Y square plus Z square square root. This is how you find magnitude for three-dimensional question. Just remember, you square the I, square the J, square the K component, square root. It's fun, just a reminder. Careless mistake will be here, your angle. Okay. Of course, this one just ignore. In the, just highlight when you write something for vector, there's an arrow or small arrow here, right? In the exam, if you forget to put in arrow also, I'll give you correct. Because why? Sometimes you confuse the alphabet. Okay. So in my slide, I will use the double line to represent magnitude. Okay. So in Cartesian, you can label the direction by alpha, gamma, beta. Okay. In Cartesian, there are three directions. Which is alpha. Alpha means from the resultant into x-axis. Okay. Alpha angle is the resultant to the x-axis. Beta is the resultant to y-axis. Gamma is resultant to z-axis. I hope you can see three triangular there because you need to find the alpha. Alpha, if you draw this one, A to AX arrowhead here, combine with the blue color, you get a triangular. Beta also same. Beta, this arrow go down, you get another triangular with the right angle 90 degree here. Gamma also same. There's a triangular here, 90 degree here. Okay. So x-axis one is here. You draw here, 90 degrees here. Okay. Again, what is the maximum angle of alpha, beta, gamma? What do you think? What is the range? What do you think? How you know your answer is correct? You must know the maximum minimum angle. Minimum? How many? 0. Right? Maximum? 180. Yeah. Means this arrow, it can from 0 to another side, 180. If your answer is more than 180, means wrong already. Means the arrow can be 0 to 180. Okay, this is what I mean, the triangular just now. Okay. So when you have triangular, you can use cos relationship. Alpha is here. 90 degrees here. Okay. So how to find cos? Why we use cos? Because the angle give you cos relationship. It's 90 degree. This is AX. Then this is your gamma is here, alpha is here. This is your A resultant. Okay, you take this blue colored shaded, you flip into the one that I drawn the whiteboard here. You can find that actually you have AX, you can have a resultant is giving you a cos relationship, side and hypotenuse. Okay, cos alpha equal to side and hypotenuse. Same with beta. Beta is here. So there is a maroon color or pink color. 90 degrees here. Beta, also cos. And AZ also same. This is equation that we expected you to write because you need to find the angle. Every time you solve vector question, you need to solve for magnitude, which is a square root of square, 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 square. All right. Then the next steps, we expect you to write this one. Cos alpha equal to something divided by something. One of it will be missing. Normally, you need to find alpha, beta, gamma in your answer. Then you need to draw where is your alpha, where is your beta, where is your gamma in the diagram, in your diagram, or in your answer. Okay, so practice how to draw three-dimensional diagram, because maybe some of you are not used to. So draw to one presentation that you should able to see where is alpha, where is beta, where is gamma. This one need practice one. You cannot do last minute one. You need to practice, at least you know how to draw. If not later, when you be in the test or final exam, only you practice, you will find difficult drawing the gamma, because you will squeeze your diagram one side. Okay. So to find the alpha, you just inverse it lah. For example, alpha, you just inverse cos AX divided by A. Apply the same for the beta and gamma. Okay. Okay. Now, you want to find the direction unit vector, right? We need to tell where is the direction. In this case, A of the direction, we call it direction vector, is given by this direction vector. We write U A. U sub A means the resultant of A. The direction of UA equal to the A vector. A vector is what? Something I plus something J plus something K. How to find magnitude? Square root AX square plus AY square plus AZ square square root. That one. You take the vector divided by the magnitude, you get UA, which is the direction of that vector. This is for three-dimensional question. Of course, you say, Dr. Ang, can I use this equation for 2D? Yes, your Z is 0. Okay. So this is the equation, UA equal to AXI plus AYJ plus AZK divided by the magnitude, square, 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 square root. So this one got marks. You write UA equal to A divided by magnitude. Then this one usually already solved in the previous solution. Already this one. This one you need to calculate at the side. Or if you're lazy, you just write inside, like copy this presentation. If you're lazy, you can do at the side. The magnitude, you can do one small portion, magnitude equal to this one, then you get one value. Then you can substitute value. Okay. Important, you need to show me how you get the answer. Don't suddenly one value come out here. You can do at the side one. Side note you can do. Okay. Now, you can rewrite this presentation into this form, which is if the question asks you what is the direction in I, you take the I ax divided by magnitude of the vector. Okay, so you axi, aya, aza, and so on. Yeah. And direction. So these two are important equations when it comes to three-dimensional that force you to use Cartesian vector notation analysis. Okay. Okay. Now UA, because just now AXA equal to cos alpha, AXA equal to cos alpha, you can represent the front one as a cos alpha, second one is cos beta, cos gamma. This is a new information for you, so it will take some time to remember this one. This equation won't be given in the test. You won't see this one in the test. We expect you to write this one, write this one, write this one in the solution. Standard. Okay. Okay. Magnitude of unit vector. Magnitude. What is the magnitude of unit vector? What mean by unit vector just now? IJK, what is the magnitude? Huh? IJK. IJK, they are unit vector, right? What is their magnitude? 1. 1. So, this magnitude, UA, is 1. What does it mean? Square this one, plus square this one, plus square this one, equal 1. This is what you learn in your trigonometry mathematics calculation. This is a cos rules, a cos formula. Cos square alpha plus cos square beta plus cos square gamma equal 1. This is the derivation for the angle. Okay. Important is everything makes sense for you at the moment. If anything doesn't make sense, you need to ask question. The rest is just memorizing. You need to memorize. Yeah. So exam time, go and practice this, and this. Write somewhere when you start. Write this one, write this one, write this one, write this one. Just in case you forget lah.
Automatically, we just say that its magnitude is 1. We don't have to do square root of 1 squared plus 1 squared plus 1 squared, right? Because IJK.
You don't need, but usually the question doesn't ask you what is the magnitude of this one. The question will ask you alpha, beta, gamma. This one you know is 1. Everyone know is 1. But the question alpha, beta, gamma will be missing. So this is only one approach to find alpha, beta, gamma. Another method is over here. Another method is over here. Means you find the answer in this form. You write this one, you equal this one equal to this one, straight away you find alpha. Or sometimes you find this one, gamma, alpha, beta already, but missing. means from the top you already have already, but answer you don't have, let's say. You're unable to find gamma, let's say that the question. So you need to use this one to solve for gamma. Okay. Remember, when you use this one, go and practice how to use calculator for square. Some of you, if you see this one, you don't know how to use already. Okay. So this one, usually this one is to find one of the missing angle. Here I highlight here. You want a quick one, you find this one. You write this one of it, alpha, beta, you can find. Gamma missing, so you substitute this one, you rearrange, you get gamma. Okay. Start from today. When the question asks you to use Cartesian vector analysis, you need to write A equal to AUA, or you write F equal to FU, that direction. Okay, you need to start to have this habit already. A is a vector. Vector have magnitude and direction. So this is the magnitude of the vector or resultant force. This is the direction of the resultant force or the force, UA. Right? So have the habit of writing in this way: cos alpha, cos beta, cos gamma. If the question asks you to find alpha, beta, gamma, usually you see this one in the three-dimensional question. Okay, then you write AX equal to this one, AY equal to this one, AZ equal to this one. Then you start solving question. Okay. The rest is just elaboration. Okay, what is different from this one and this one? Huh? When you have a horizontal vertical angle, it's a bit different from the previous one. Huh? Alpha, beta, gamma is measured from the vector to the axis. Huh? The vector to the axis. It can be any forces, it can be resultant. As long as it's vector, you're able to find alpha, beta, gamma. Alpha, beta, gamma is from the vector to the axis itself. This light is the vector plane. This is a plane vector to the, we can say, vector to the component of the vector. For example, this phi is A, the blue arrow, to the ZAZ vector. Then this theta is A prime to AX. You should understand how to get A prime, right? You split the blue arrow into AZ and A prime. So this is a horizontal angle and vertical angle. Don't confuse with horizontal angle and vertical angle with alpha, beta, gamma. This is on the flat plane, flat plane. Flat plane. It's a flat, like piece of paper here, piece of paper here. So this one also right angle over here. So cos equal to this and this. Here also right angle. So cos equal to this one and this one. So it's sine, sine. The rest you read. So you start to see sine cos rules, cos sine rules. This one in your mathematics 2 or 1. This one is information. It takes some time to digest. For horizontal vector angle, phi and sine is in this form. A bit lengthy. a bit lengthy, but for today, you just for your info, this is just to remind that okay, I've seen this one. I have seen this one, huh? So if this kind of question come up in test one, I'll let you know. But there is a slide in the horizontal and vertical angle. Okay. The rest to read, huh? Okay. The rest you read. So again, you should not memorize, but you should understand. When you label the diagram, you should know how to find the sine and cos component. And then you derive from there. Huh? You should not memorize, but you should able to split the forces still same, huh? Split forces into respective axes, then you combine them together. Okay. Now is the operation of vector, just a revision. When you add two vectors together, let's say you have vector A, vector B. Vector A have ijk, B also have ijk. When you add them together or you minus them together, add means you add together, minus means they go opposite direction already. So let's say you have this presentation, you have R, okay, you have the R. So resultant R equal to A plus B, means you split into A and B. Resultant equal to, let's say you have two vector lah. Vector A plus vector B. Vector A have ijk equation, B you have ijk equation. So if you have vector R, this vector R is a combination of these two vector. You combine them together. What is should you write here? In I? Should be what? AX plus BX. Here, AY plus BY. This one, same lah. This one you already repeat in the previous tutorial question already. Okay, so this is same lah. Means if you find the resultant, you can find in X direction, Y direction, Z direction. Okay. Okay, simple one. This one you should able to know lah. Express force as shown in Cartesian vector. So, can you find? Do you know what the question want you to do or not? You want you to write F equal something I plus something J plus something K. So before start, you should know which one positive, which one negative already. Yeah? How you know? You split the component first. You need to do 2 times in 3-dimensional question. So this one, 100 here, split into 2 forces. How you split? Open your finger. Put like that. Your thumb and your index actually always 90 degree one. If you open spread, always 90 degree. So put like that. When you split, means this one to Z and to here. Do that one set lah. Okay. So this one you don't know ma. You just write F prime. No? If you don't know, you just write F prime. No? So you have 1 direction, 2 direction, 1 component, 2 component. This one already landed in Z. You are safe. But this one not safe. This one half. So what you do? Open your finger again. Like that. Okay. So this one split into this one and this one. You should already know lah how to do already. This one we already repeat many times. So what is negative? Which one negative? I, J, or K? Which one negative? Based on the splitting of component. I positive, negative. I positive, because arrow pointing this way. J, negative, because when you split this one, it pointing this way. It pointing this way. So negative value here. K positive, go up. The rest is using cosine rules, the tangent, cos, or trigonometry lah. Okay, you're given angle ma. So you should know whether which one is sine, which one is cos. Okay. So remember, always split your force first into component when you see this kind of question, or even 2D question. Split into forces first. If your tangent, sine, cos, koyak, then you need to go and practice lah. So I just highlight lah. So you go to split these two, fz. If you don't know, you just prime. Then after you do, then you split into this one, split into the two forces. Remember to draw the parallelogram every time you do. Draw the parallelogram. Once you have all this, you have fz, fx, fy, fz. Put inside here. Fx here, fy here, fz here. So write fxi plus fyj plus fzk. Then remember that your fy is negative. Just remember to use the bracket because you want to use the Newton here. If you're hardworking, you just Newton without the bracket lah. If you're lazy, please use a bracket lah, curly bracket. Okay, remember negative sign for the component that's opposite the axis. Magnitude, very easy. Square this one, square this one, square this one. Although this one negative, but inside square it still become positive. Direction is another, this one you substitute. Direction, how to do? So this one, I just put a highlight. Direction means sometimes you need to find the alpha, beta, gamma. Right? Or it will be in a IJK form. Okay, which is this one. After you find magnitude, you need to find direction. Start with U equal to F divided by magnitude of F, means vector divided by magnitude. So put in the answer from a previous one, put here. Magnitude already find just now. This one divided by this one become the X. This one divided by this one become the Y. This one divided by this one become. So this one, the unit direction for the resultant force will be this one, this one, this one. And this for this force, the direction is represented by this one. Okay, represented by this one. What does this number means? 0.354. If you go to a diagram, where is 0.354? Where is x? Here, x, right? 0.534 is here. Where's y? Negative, go here. Then this one, 0.866 is here. Okay, so it's in this form. You need to write F equal to F UA. Okay. So this one equal to this one. Right, this whole thing. So A cos alpha equal to this one. Okay, means this one equal to cos alpha, cos beta, cos gamma. Understand? Huh? This one, this is cos alpha, cos beta, cos gamma. You inverse the cos, you get alpha, beta, gamma. Make sense? Huh? Then at the end, again, once you split, there are two diagrams you need to draw. One is the split into component diagram. Another one is the direction diagram or the resultant diagram. Okay, so the answer for this example 11, the answer asks you about this force. So copy the force, find the angle, draw the angle. Where is alpha? Where is beta? Where is gamma? Again, what is alpha? Alpha is vector to x-axis. Vector to x-axis. Okay, beta is vector to y-axis. Vector to y-axis. So label correctly. Show me the arrow. Where is the angle? Gamma is vector to z-axis. Three significant figures. Three significant figures. So I put here already, reminder, you are required to draw this one as a complete answer. If you solve without this one, you will miss mark for this diagram. Usually 2 marks minimum. This one. But draw one, usually I'll give more marks. Yes. X, Y, Z. At this moment, no need. At this moment, no need. Okay. Example 12. Same. Go home. This is your homework. Go home and see. You need to split magnitude of F2 so that resultant force act along the positive Y has a magnitude. This one. This one is the reverse question. Just now, the question is from resultant to individual forces. This one, you are given individual forces. You need to find, you are given the resultant. You need to find F2. Okay, you are given F2 and F1. You are given FR. FR direction give you already. FR is along positive y-axis. Your resultant is over here. Resultant is over here. So in the answer, you need to draw the resultant given in the question. Magnitude also given. Reverse the question. Need to find write the magnitude equation. Write the cos alpha beta equation. Then write the complete equation. You will see what is missing. Substitute, then you get answer. Okay, this is your homework. All the question, all the answer is there. Okay, so there's some extra homework there. We continue position vector tomorrow. Tomorrow.